Here's a trigonometric example for finding relative extrema using the first derivative test. So it's the same as all the other examples, except this is just trig. So a lot of times on the trig, they'll limit the domain like this on 0 to 2 pi, which means one time around the unit circle. If they don't, you'll have sometimes infinite number of mids and maxes because, as you know, trig functions can look like this, and then the problem will never end. So we're only going from 0 to 2 pi for this question, and you do it just the same as all the other questions. You find the critical numbers. So to do that, you determine the derivative and find out where that equals 0. So the derivative of sine is cosine, and the derivative of cosine is negative sine. You have to figure out where this equals 0. So now, to figure out where this derivative equals 0, I'll just start solving like this. Cosine x equals sine x. Well, there you have it. This derivative equals 0 where cosine and sine are the same thing. So you have to kind of remember your unit of circle. Cosine and sine are always the same, root 2 over 2, on the 45-degree angles or the pi over 4 angles. So pi over 4, 3 pi over 4, etc. But they're only the same when they have the same sign. So if you think about which angles that has to happen at, it has to be this one where they're both root 2 over 2. And this one where they're both negative root 2 over 2. On the other two, this one and this one of them is positive and one of them is negative, so they're not equal. Therefore, the critical numbers where cosine and sine are equal are this angle, which is pi over 4, and this angle, which is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And then you could go on to say 6, 7, 8, 9 pi over 4, etc. But 0 to 2 pi means just stick with one revolution around the unit circle. All right, so we have our critical numbers. So now we make our chart. Get rid of this. Oops. That. So now we make our chart. Now the difference between this and other charts we have made is when we did the other charts, we went from negative infinity to infinity. Now this chart, we're sticking with this domain, which I've just lost here, of 0 to 2 pi. So we're going to start at 0. Oops. I'm losing it. There we go. So we're going to start at 0 and end at 2 pi. And the critical numbers are pi over 4 and 5 pi over 4. So our intervals are 0 to pi over 4, pi over 4 to 5 pi over 4, and 5 pi over 4 to 2 pi. So now in this interval, a number between 0 and pi over 4, that's going to be tough, but you can use 0 because 0 was not a critical number. So even though it's not technically in the interval, we know it's not a critical number, so it won't change there. So when you plug 0 into this derivative, you'll get the cosine of 0, which is 1, minus the sine of 0, which is 0, so it's positive, minus 0. On this next interval, pi over 4 to 5 pi, I would use this number right here, pi over 2, because that's easy. And f prime of pi over 2. I missed the prime over here. So the derivative at pi over 2, again, plug it into this derivative. Cosine of pi over 2 is 1. I'm sorry, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we have 0 minus 1, which is negative 1. Finally, on this last interval, 5 pi over 4 to 2 pi, which is this interval, I'm going to use this number, which is 3 pi over 2. The reason is because it's just easy. If you plug in 3 pi over 2 to this derivative, the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is negative 1. So you have 0 minus a negative 1, which is a positive 1. Okay. So hopefully you understood that. It is a little sloppy. I'm just going to, if you don't mind, I guess you don't mind. You do, you just fast forward or delete the video. I'm just going to kind of talk about where I got all of these test points. This was my first critical number, pi over 4, unit circle. This was my second critical number, 5 pi over 4. So my first interval, I did this. I decided to use 0, which is at the point 1 comma 0, which means cosine is 1 and sine is 0, and that's how I got this number. My second interval was from pi over 4 to 5 pi over 4, so I could use anything in here. I decided to use this test number, pi over 2, where this is at 0 comma 1. Cosine is 0 and sine is 1. You could have used pi, which is just as easy, and you would have gotten the same results. And then this last interval, 5 pi over 4 to 2 pi, that's here. I decided to use this number in the interval, which is 3 pi over 2 or 0 comma negative 1, because it was easy. So that's, I just wanted to make it a little bit clearer how you could do that easily with the unit circle. So our results, our conclusions. We are increasing on the interval 0 to pi over 4. We are decreasing on the interval pi over 4 to 5 pi over 4. And we are then increasing again on the interval 5 pi over 4 to 2 pi, which means we have a relative max at the point pi over 4 comma whatever, relative min at the point 5 pi over 4 whatever. Now, the whatever part, our original function was sine x plus cosine x. So always plug into the original function. If you plug in pi over 4, they're both root 2 over 2. So you'll get root 2 over 2 plus root 2 over 2, which is 2 root 2 over 2, which is root 2. And if you plug in 5 pi over 4, you'll get negative root 2 over 2 plus a negative root 2 over 2, which is just the same, except you'll get negative root 2. And you can use your calculator to check those. That's it.